One of the most important network performance factors is the throughput. Throughput, generally speaking, is a lower layer phenomenon, but some researchers also refer to the application layer throughput. We shall come across both the lower layer throughputs and application layer throughputs in respective times. In this module, we shall see what is throughput and what relationship does it hold with the load offered to a network. Throughput, in simple mathematical representation, is the summation of the good put and the bad put. Good put is the packets which are transmitted from the sender, are received by the receiver without involving retransmissions. Bad put owes to the packets which are retransmitted and are hence received at the receiver. So the total number of packets which are received by the receiver, either corrupted or healthy, contribute to the throughput. So the quantity of error-free data which is transmitted per second on the communication channel involves the throughput. Of course, the packets which are erroneous would have futile transmissions, but these futile transmissions certainly contribute to the throughput. Of course, we understand that the channel capacity of a given network is given by the expression C is equal to B log of 1 plus S over N to the base 2. This channel capacity is the maximum that could be offered or extracted from a network. Throughput only achieves a fraction of it. This graph establishes relationship between load which is offered to a network and the corresponding increase in the throughput. When we start increasing load in a network, we would only go to the upper limit of the capacity. So we start increasing the load. According to the increase in load, the network starts to make transmissions and getting receptions. So with increasing load, the throughput increases. But we see that there is a breakage point. It's called the rupture point, which is kind of deviation from the ideal behavior of the network to a more practical one. This deviation occurs because the transmission media under consideration may not be perfect. The devices might have limited resource availability in terms of processing power, the memory availability, and the network might consist of an exceedingly large number of nodes. So if we apply the limitations of all of these respectively to a network, the throughput is going to fail off beyond a certain point, the rupture point.